है? हाँ हाँ माप। तू केम आई नहीं?
हेलो दोस्तों, कैसे हो आप सब लोग। लाइक जैसे आपने देखा यहाँ पर एक ब्रिज है, रिवर है, ओवरफ्लो रिवर है, फ्लड लाइक सिचुएशन है, राइट। ओके, सो सिमिलर वे इन आवर नीट एग्जाम ऑल्सो वी हैविंग सम लाइक numericals, but like here we don't have that flooded river, but instead of like normal river will be there, and over that one bridge will be there. So let's read such question. So here a horizontal bridge is built across a river. A student standing on a bridge throws a small ball vertically upward with velocity 4 meter per second. The ball strikes the water surface after 4 seconds, and they're asking the height of a bridge above water surface, and we need to take g as 10 meter per second square. Okay, so it was a question asked in NEET 2023. Let's do understand it. Okay, so here like we're having that bridge. Okay, and then here we're having that river. Okay, so bridge is built over the river. Then one boy is there. Okay, who has thrown one ball in upward direction. Right, with some velocity. Okay, then with velocity 4 meter per second. So initial velocity of that ball is what? 4 meter per second. So u is given that 4 meter per second. Then that ball reaches some height. Okay, then it reaches that height here. Then it comes back. Okay, then that ball comes back. And then it like falls over the surface of that river also, which means that ball is falling in a river itself. Okay, so let's extend its motion. So here it falls chapak say, and what they're asking the height of the bridge. They're asking us this height of the bridge above the level of the water, this height, right? एंड व्हाट हैव गिवन द टोटल टाइम, मतलब यहाँ से जैसे पहले फेंका था, देन जब वो बॉल गिरा वाटर में, तब तक जो भी टाइम है ना, सो दैट दे आर आस्किंग. सो नो नो, दैट इज गिवन, दैट इज व्हाट 4 seconds. So total time is given, that is what 4 seconds. Let's consider the t1 here, when that ball moves and reaches a maximum height, then t2 when it comes back, and like it comes back over the bridge again, and from that, from bridge to water, it's considered, that is what t3. Now, as we know that, see the velocity and like the medium remains same, so the T1 will be same as the T2, right? So we having that condition here, the T1 will be same as the T2. Okay, as the height is again will be same. Now, as it reaches the like that maximum height, we know that its velocity will become zero, right? And then it will come back. So what we'll do, we have, see, we have here initial velocity, we have final velocity, right? We don't have the time, but we can find out the time as the we can take the g value. So g needs to be taken as 10 meter per second square, right? So we can take that g. We're having initial velocity, we're having final, we're having that g. So we can find out the what I can say, the height between that bridge to it's like height between, just 1 minute, that height bridge to that maximum height where that ball has reached, so that we can find it out. Okay, let's consider that as a h1. Okay, so how we can find out? Using Newton's third equation. So what's that Newton's third equation? That is what v square, okay, right, minus u square is equal to 2as, where the a is what? G. Okay, so s will be, let's say your s is what? H. That will be v, how much? 0, 0 ka square 0, minus u, how much it is? U is what? 4, 4 ka square 16, divided by 2a. So 2 into a how much? A is what? 10, right? So 20. So you will get height there minus, oh yeah, the acceleration you need to take as the minus. So what we'll do, we'll take that acceleration as negative, right? As it is moving in upward direction opposite to the that g. So it will be 2 into minus 10. So you'll get minus minus will cancel. You will get the 16 divided by 20. So how much? It's a h1. So okay, like 2 eights are, and then divided by 10. So you'll get the 0.8. That's what the height above, what I can say about that breach. Okay. Now, yeah, that's what the point is. Now the next thing we'll find out the time also. Now we're having s, right? We're having that height, we're having initial velocity, we're having final velocity. So we'll find out the t1 and t2. Just one you need to find out, so you can equate it. So let's find out the t1. We'll use the Newton's first equation. Okay, v is equal to u plus at. V is equal to u plus at, where the t is what t1. V is what final velocity, that will be the 0. U is what 4 meter. Okay, so 0 is equal to 4. Okay, again here you need to take the a as minus 10. Okay, and then into time 1. So it will be, let's say, t1 will be, we can take that minus 10 t1 on the other side and like make it plus. So t1 will be 4 divided by 10. So the t1 will be 0.4. Okay, similar way the t2 is also 0.4, as acceleration like will be same. So t2 will be again 0.7. Okay. Now t3. Okay, so they have given like total time t1 plus t2 plus t3, right? T1 plus T2 plus T3. That is what 4 seconds. So what we need to do, we need to find out that h. Okay. So T2 plus T3 as it is rakhenge. T2 plus T3 will be 4 minus T1, and how much T1 is what? 0.4. So you'll get it is 4 minus 0.4 will be 3.6 second. Okay, so that is what t2 plus t3. That is what the time when that ball comes from after reaching that height, and when it falls in a that river water, right? So that much time t2 plus t3, right? So let's again use the same equation. Okay, uh, like we need to find out the h, right? So what we'll do, we'll take that motion from its reaching maximum height, मतलब ये इस ज्यादा हाइट पर है, तो वहां से वो सीधा पानी में आएगा ना, क्लियर? तो वो वाली कंडीशन हम यहाँ पर यूज करेंगे। तो वहां पर देखो इनिशियल वेलोसिटी, अब ये जो भी v यहाँ पर लिखा है ना, ये एक्चुअली इनिशियल वेलोसिटी होगी उस केस के लिए। तो इनिशियल वेलोसिटी 0 है। ओके, देन फाइनल वेलोसिटी ये यहाँ पर आके मतलब स्ट्राइक होगा। देन यहाँ पर g हमारे पास ऑलरेडी है, सो वी हैविंग, we don't have a final velocity. So what we'll do, we'll use the second equation, right? So second equation क्या है हमारा, s is equal to ut plus half gt square और the at square, ठीक है? So s कितना है, s will be h1 plus h, right? h1 plus h, ठीक है। u कितना है, इनिशियल वेलोसिटी फॉर दैट मोशन इट विल बी 0। हम क्या कर रहे हैं यहाँ पर, वो बॉल जो मैक्सिमम हाइट पर था वहां से वो पानी में गिरेगा ना, वो वाली मोशन हम यहाँ पर लेंगे, राइट? सो ये बिकम, इट विल बिकम 0 प्लस हाफ इंटू जी। अब ये नीचे आ रहा है तो प्लस ही लेना पड़ेगा जी। ओके, इंटू टाइम हाउ मच वी हैविंग 3.6, राइट? सो 3.6 का स्क्वायर मतलब 3.6 इंटू 3.6। ओके, सो h1 how much we having, h1 0.8, 0.8 plus h, that height of the bridge above the water, then 0, it will be 2, let's say यहाँ पर करेंगे 2 5s are, right? So 5 into 3.6 into 3.6, okay, तो 3.6 का स्क्वायर अगर निकालेंगे, so I think इसका स्क्वायर कितना आएगा, like 3 का स्क्वायर 9, 6 3 18, 36, 9 6 का स्क्वायर 36, okay 6, then ये 9, then 12, okay, so 12.96 इसका स्क्वायर आएगा। So h will be 5 into 12.96 minus 0.8. So h will be, चलो 5 से मल्टीप्लाई करो, 5 6 30, then like 5 9 45 plus 3 48, okay, then 4, then 5 2 10 plus 4, and 1 5 1 6. So and that 1 2 zeros, okay, so it will be 64.80. 64.80 or like 64.8 minus 0.8. So obviously you will get the h will be 64.8 minus 1.8, it will be 64 feet. Okay, so here the height of that, what's that? Height of the breach above the water surface. So that will be 64 meter. So which one is correct here? That B1. Okay, chalo. So keep learning.